Okay, everybody, let's get started. So at the end of the last lecture, we were talking about constructors of a class, and we were at this constructor here. So this is the constructor that lets the caller initialize a new point to the coordinates that they specify. Right? Now, in this in this constructor, you've got parameters x and y, right? But remember, the class has fields x and y. So inside the constructor, when you want to refer to the field, you have to say this dot x. And when you want to refer to the fields, you have to say this dot x and this dot y. Right? If you just refer to the name x or y, you end up referring to the parameters, right? Which is not what you want in this. Which is not what you want to do in this example. Right? You don't want to write x equals x and y equals y, because that effectively does nothing. Okay, now the reason for adding this constructor is so that it's easier for people who are using your class to use the class. Right? So when you add this constructor on top of the no argument constructor, right? People who are using the point2 class can now create points by specifying the coordinates of the points when they make the point. Right? If you don't provide this constructor, then people have to make a default point, 0, 0, and then they have to set the coordinates of the point. Right? So this saves the users of the class some work. Right? So instead of writing code that used to look like point2p equals new point2, right? Using the no argument constructor, and then forcing the user to set the coordinates of the point manually, right? You can just write that. Right? So you save them a line of code. It's also, arguably, it's easier to read this than it is to read the previous slide. Right? So at a glance, you can tell that the point p is going to have the coordinates -1 and 1.5. Okay, so that's I guess what's called it doesn't really have a name. It's just a constructor that you create for the class. Right? So I think I called it a custom constructor or something like that. Yeah, custom constructor. So this is a constructor that's it's not a no argument constructor, and it's not a copy constructor. So a copy constructor is the other special kind of constructor in Java. Right? So the purpose of a copy constructor is to initialize the state of an object by copying the state of another object, right? Having the same or a compatible type. Right? So this one always has a single parameter that's the same type as the class, right? Because you're going to copy another object of the class. So the point2 copy constructor, right? Its name is point2 because it's a constructor, but its parameter is another point2 object. Right? And so the idea here is you're going to initialize the coordinates of this point by copying the coordinates of the other point. So in this constructor, you write this dot x equals other dot x, and this dot y equals other dot y. Right? Now, you might wonder why you can access the fields of other directly. Right? I think you all understand why you can access the fields of this object directly, right? Because that's the object that you're initializing. But why can you access the fields of other directly? It's because other is a point2 object, right? And we're inside the point2 class. Right? So inside the point2 class, the fields x and y are visible to the class no matter what object you're using. Right? No matter which point2 object you're using. Right? So if you pass in a point2 object, you can access the fields of that point2 object directly by name. Right? So you don't have to go through a method or anything else. Right? Now, there's a common error here. So one of the common errors that new programmers make is they write other x equals this dot x and other y equals this dot y. Right? You don't want to do that. What you're doing is you're changing the coordinates of the other point, and that's not what you're supposed to be doing. Right? You want to initialize the coordinates of this point. Right? So it's always this dot x on the left-hand side, and it's always this dot y on the left-hand side. Okay. So when you have a copy constructor, again, that lets your user of the class, it simplifies their life in a small way. Right? So here's an example where we're going to copy a point. Right? So point p is the point -1, 1.5. Right? And then q is just a copy of p. Right? But it's an independent point. So it's a new point, because you call the constructor. You use new to call a constructor. Right? So you have a new point q. Right? That point q has the same coordinates as p. Right? So when you print them out down here, right? You see P is -1 and 1.5. Q is -1 and 1.5, right? But P and Q, they're distinct objects. So if you change the coordinates of P, right? P's coordinates change to 99 and 44, right? But the coordinates of Q don't change, right? So you have two distinct point 2 objects here, right? It's just that when you made Q, you copied the coordinates of the other point, right? But it's not the same point. So they're now independent objects after this line, right? OK, now, the three constructors that we have for point 2, there's a no argument constructor, there's a 2 argument constructor, and there's a copy constructor, right? They all do the same thing, more or less, right? So what do? Well, first of all, in this example, they all have 2 lines of code, right? And they do exactly the same thing. They assign a value to this .x and this .y, right? So there's a lot of code repetition that's happening here. In this class, it's very small, right? Because it's just 2 lines of code. But there is code repetition that's happening, right? And so whenever you see duplicated code, right, the idea is you should find some way to avoid duplicating code, right? So the mechanism is you call a method. So you put the duplicated code in a method or something else, right? And then call the method whenever you want to run your duplicated code. Now here we've got constructors. So what we would like is we'd like to put the most general case of the constructor in one constructor. And then we'd like to call that constructor from the other 2 constructors, right? So we want to put all the common code into one constructor and have the other 2 constructors call that 3rd constructor. So the way to do that is with a mechanism called constructor chaining. Okay? So a constructor is allowed to call another constructor, right? So that is allowed. And when a constructor does so, we say that we call that constructor chaining. Right? Now the way you chain in a constructor is you use the keyword this. Right? So Java is a little bit bad in this respect in that it recycles keywords. Right? So now this now takes on a different meaning. Right? So instead of referring to a field of this object, right, this is now going to be the way to call another constructor inside the same class. Right? Now, if you decide to do this, you're only allowed to do it in one place in the constructor, and that's on the first line. Right? So you can't do it on the last line, you can't do it on the 3rd line, you have to do it on the first line. If you try to put it anywhere else, the compiler will tell you that it's an error. Right? And furthermore, you cannot use this inside of a method to call a constructor. Right? So if you're inside a method and you want to call a constructor, you use new, and then you call the constructor. OK? So we're going to use the word this to call the constructor. The way it looks like is as follows. Right? So it's that second constructor that we implemented that's the most general constructor in this case. Right? It's the most general because it lets you set x and y to whatever you want. Right? The first one sets x and y to some specific values. The third one sets x and y by copying another point. Right? So it's the second one that's the most general case for setting x and y. Right? So the idea is put all your common code into the middle constructor here. Right? And then for the first constructor, if I want to set the coordinates of the point to 0, 0, I write this, round brackets, and then 0, 0. And so what that does is it calls the second constructor. Right? It's not point 2, 0, 0. Right? It's not new point 2, 0, 0. It's not new this 0, 0. It's just this 0, 0. Right? And that calls the second constructor. Right? The second constructor runs and then comes back up to the first constructor. Right? There's nothing left inside the first constructor body, so it returns back to, so it goes back to new. Right? And then new returns the address of the object. OK, what about the copy constructor? Well, the copy constructor is supposed to copy the other x coordinate and the other y coordinate. Right? So I can just pass the other x coordinate and the other y coordinate to the second constructor and let the second constructor do all the work. Right? So in other words, it sets the x coordinate and the y coordinate of the point, comes back to the third constructor. There's nothing left in the third constructor, so the third constructor returns back to the new operator. Right? And then the new operator returns the address of the object. Right? So in this example, you don't gain very much. Right? You basically save one line of code here and one line of code here. Right? So there's not much gain here, but that illustrates the principle of constructor chaining. Right? So this becomes useful when you have a class that has more than 2 or 3 fields. Right? So if you have 4 or 5 or 6 or 7 fields, right, you don't want to, in every constructor, to be writing 6 or 7 or 8 lines of code over and over and over again that do the same thing. Right? You put it into one constructor and then chain to that constructor. All right? Any questions about that? OK. Now what about the counter class? Right? So the counter class is, well, it's even simpler than the point2 class. It only has one field. Right? So we already have the no argument constructor, which sets the counter to 0. You can create another constructor that sets the counter to some specified value. Right? And you can also add in a copy constructor. Right? And then you can use constructor chaining to minimize all your code duplication. Right? So the no argument constructor now, I'm going to change that so that it calls some other constructor. Right? So it's going to call the constructor passing in 0 for the value of the counter. Right? My second constructor now looks like this. Right? So we can't have a counter whose value is negative, because that's the abstraction that the class is trying to provide. Right? Our counter class starts at 0, goes up to some number. Right? So if I pass in a negative number for the value, I should indicate to the caller that that's a mistake. Right? How do I do it? I throw an exception. Right? And then I just set this value equal to the value. The copy constructor simply calls the second constructor by passing in the value of the counter to copy. Right? So again, the copy constructor has its parameter has the same type as the class. Right? So inside the counter class, the copy constructor always looks like counter as the parameter. Oh, OK. So that's not the end of the lecture. Right? On to the rest of the lecture. OK. So that's basically all there is to say about constructors for the time being. Right? A little later on, I guess, when we talk about inheritance, constructors will reappear. But for now, you should be able to create simple classes and write constructors for those classes. Right? The important thing to remember for constructors is you should be setting all of the fields in your object, at least for the time being. All right. Now, the less fun part about programming is documenting. Okay? So you know from your previous courses that you should be documenting your code, right? You may have been shown doc strings in CISC121. You may not have. It depends on who taught the course, right? So documenting code was not a new idea when Java was invented, right, in the early 90s, right? But what Java did do, it was the first major language where it was decided that you should embed your documentation into the code, and then you would use an external tool to extract that documentation to produce a nice document for you. Right? So when you Google like Java string or something like that, and you find the Oracle page that contains the string documentation, that's all generated with a tool called Javadoc. Right? And if you go and actually look at the string class, you will find all of the documentation for the string class inside the class itself. Right? That nice web page that's produced is produced by a program that reads the comments and makes a document from that. Right? So this Javadoc tool processes something called doc comments. Right? And a doc comment is a comment that's immediately before the class, a field, a constructor, or a method. Right? So they appear immediately above the thing that you want to document. Okay? They always start with /**. Okay? And they end with //. Right? So remember the standard multi-line comment in Java is /*. Right? /** indicates a Javadoc comment. The doc comment itself can be written in HTML if you want it to. Right? Normally it's just plain text. Right? But then Javadoc turns it into HTML. Right? It's made up of 2 parts. Right? First of all, there's a description. Right? So there's a brief description of the thing that you're documenting. Right? So the class, the method, the field, whatever it is you're documenting. Right? So the first sentence of your doc comment, right, gets turned into the summary section for the thing that you're documenting. Right? So when you look at the documentation for a class, right, there's a summary of all the features, and then at the bottom there's the detailed comments. Right? So it's that first sentence that defines what appears in the summary. Only one script. Okay, and then for a Javadoc comment, it's all inside of one of these. Right? So it's all one big comment. So if you want paragraphs in your comment, you have to use HTML to break up the comment. Right? So in other words, you have to stick in a p tag, which is a paragraph tag in HTML, to separate paragraphs of your documentation. So I'll show you an example of that shortly. So that's the description, right? So that's all the description of what the class, field, method, or constructor is supposed to do. But then, in addition to that, right, you can describe what parameters does the constructor or method have, right? What does the method return? What exceptions might be thrown by the constructor or method? Right? And so these are called block tags. There's actually a bunch of other ones, but those are the only ones we care about for now. Okay, so how do you write your doc comments? So you begin with the class, right? So every class should have a Javadoc comment that describes the purpose of the class. It doesn't have to be long, right? But there should be some comment that describes what is the class for. Right? So if you look at the source code for point 2, you will see the Javadoc comment for the point 2 class. Right? It tells you simply that the point 2 object represents a Cartesian point in 2 dimensions having real coordinates. Right? When you run the Javadoc tool on this class, right, what you end up with is something that looks like this. Right? Now the package is wrong because this is an old version of the slide, and I didn't want to rerun Javadoc and then do another screen capture again, right? But up here you'll get the package of the class, right? You'll get the name of the class, and then you'll see the description of the class appears at the top. Right? So whatever you wrote here now appears here in the Javadoc document. Okay, so you should document your class, right? Then, if you have any public fields, you should document those as well, right? So basically, you want to document anything that's public inside your class, right? If it's private, you don't have to document it, and you can tell Javadoc not to generate the documentation for it, right? But if it's public, you should document it, right? Because anything that's public is meant to be used by someone else. Right? Again, the first sentence of your Javadoc comment appears in the summary section. Right? So this is from java.lang.math. Right? There's two fields. There's two public fields called e and pi. Right? And if you read the documentation for those, right, you'll see that for e, it's the double value that is closer to any other to e, and then blah, 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 blah. Right? And for pi, it's the double value that's closest to pi. Right? So that's what actually appears in the math.java. Right? When you generate the Javadoc for this class, right, in the field summary section, what appears is the name of the field, right, any modifiers that are on the field. Right? So E is public and static and final. Right? So you see you see static and double. It's that's fine. You see static and double. If you go down to the detailed section, you'll see all the other modifiers. Right? You'll see the name of the field, and then you'll see the one-line description. The first sentence of your Javadoc comment appears here. Okay? Okay, now what about your constructors? Well, if they're public, you should document those too. Right? Again, the first sentence appears in the summary section. The rest of the documentation appears in the detail section. Right? So here's our point 2 constructor. Right? This is the no argument constructor. So we say it initializes the coordinates of the point to 0, 0. Now this is a little odd. Right? So if you just wrote round bracket 0, 0, round bracket, the documentation will look fine. Right? It'll look fine. But all of this will appear in the same text. Right? So it'll all appear in something that looks like, do I have an example of it? Sorry, hang on. What's going on here? Okay, so it'll appear, The coordinates of the point will appear in the same font that the rest of the text appears as. Right? If you want something to appear in a programming font, right? So that's a mono-spaced font, right? So all the words take up the same space, right? Then you can put that thing inside of braces and slap @code in front, right? So that will make this stand out like that, right? Like that. So it shows up in a different font. Right? So if you ever want to indicate some sort of literal, like true or false, right? In this case, if you want the coordinates of the point to stand out, or if you want something like a class name or a method name or something like that, right? Something that appears to be a programming element, right? You can, if you so choose, you can put it in an @code. I don't know what it's called. Inside braces and then @code in front, right? And so that makes your documentation look a little better, right? It's a little easier to read, right? For the purposes of this course, when you generate your documentation, I don't really care if you put it inside. I really don't care if you put this in, right? I care more that you actually write the documentation than you make it look really nice and pretty, right? Any professional programmer, though, who writes documentation will do stuff like this. OK, so if the constructor has parameters, every parameter gets its own @param tag, right? So you should describe the purpose of every parameter, right? So the 2-argument constructor, right? At the bottom, so after the description, right? You now document every you document every parameter, right? So the tag is @param space and then the name of the parameter, right? And then a brief description of what the parameter is supposed to be, or what it represents, right? So the parameter x represents the x value of this point, right? And the parameter y represents the y value of this point. OK, that's good. I don't know why this slide's here. It should be somewhere else. But anyway, you can see, I guess here. Oh, I missed a slide. OK, so you can see here, I'm using @code to highlight the x, y, right? Whenever you refer to a parameter, right, you can also use @code to indicate, to make those stand out as well. Yeah?
In this case, is @param an override?
Sorry?
Like when you have
Yeah.
before, like last lecture, was it an override?
Yeah, last time it was override, so that's a different type of tag. That's a different type of annotation. Yeah. Right. Anything with an @ in front of it indicates that this is an annotation of some kind. And so some other thing, some other tool or program will understand how to read the annotations. Right? But the compiler doesn't care about them, except for @override and some other tags, some other annotations. Right? But here, this is a Javadoc annotation, so only Javadoc understands what this is. OK, so here's the copy constructor documentation. Right? So description, right? @param to document the parameter other, right? So @param other. There's no colon, there's no hyphen, there's nothing here, right? Javadoc will insert the separator for you, right? So it's just @param space other and then a description of what that parameter is. Right? And down here you can see the summary for those constructors. OK, if you go to the constructor detail section, right, notice in the summary you don't get a description of what the parameters are, right? You just get the one-line description of the constructor. It's in the detail section where you'll see the full documentation for the constructor. Right? So here's where you see the documentation for any parameters, return values, exceptions, etc. OK, so that's your constructors. Now methods are more or less the same thing. Right? Every public method should have a Javadoc comment. Right? If the method has parameters, every parameter should be documented with an @param tag. Now, if a method returns a value, it should be documented using an @return tag. OK? So set returns a new point, or sorry, returns a reference to this point. Right? So when I document that, right, after all of the parameters, right? You then document the return tag. So at return, what does it return? It returns a reference to this point. Right? And if you go down, if you generate the documentation and then go look at the detailed method description, you'll see that it returns a reference to this. These should be points. This is an old, this is generated from an old version of the class. Right? No, this a reference to this point. Yeah, that should be point. Oops. Okay. Now, if your constructor throws an if a constructor or method throws an exception, you should document what exceptions can be thrown. Right? And that's documented using an @throws tag. Right? So notice there's a bit of a discrepancy here. Right? So the throws tag includes the S. Right? The return tag does not include the S. Right? So it's not @returns. It's @return. Right? Here it's not @throw. It's @throws. Right? And I'm not sure why that discrepancy is here. But anyway, after your return value, that's where you document your exception. Right? So the way you document the exception is @throws, the type of exception that's thrown, and then a description of when the exception is thrown. Right? So for the counter constructor, it throws an IllegalArgumentException. When does it throw the exception? Well, if the value is negative. Right? And when you go and look at the constructor detailed description, you'll see the documentation for all the exceptions that might be thrown. Okay, so inside your Javadoc, if you choose, right, you are allowed to use a subset of HTML. Right? You're not allowed to use the full set of HTML tags and other features. Right? You only get to use a small subset of them. But one of the things you can use is the P tag to indicate that there's a paragraph somewhere in your documentation. Right? So for example, if you have longer documentation, it's nice to break it up into paragraphs. So here's the documentation for add in the point class. Right? So this method adds this vector to this point, to the point. Right? So it tells you, it adds a vector to this point, changing the coordinates of this point. P, so this is going to make a new paragraph. Right? If you just put in a blank line, you don't get a new paragraph. Right? It's all merged into one paragraph. Use this method when you want to write something like P equals P plus B. Right? And so when you look at the documentation for this, right, you see that there is, in fact, a new paragraph that starts here. Right? And so some of your classes or methods or constructors will have very long and detailed documentation. Right? And that's where you really want to use paragraphs to break up the documentation into readable chunks. Okay? Okay, so there's writing good documentation is not easy, and it takes a lot of time. Right? If you go on to write code professionally, though, it is important that you actually learn how Java programmers write their documentation. Right? So there is a fairly large set of guidelines on how you should write Javadoc. Right? It actually specifies the type of grammar you should use, the verbs you should use, nouns you should use, and things like that. Right? And that's all so that you can generate a standardized documentation for classes. Right? I guess the basic rule of thumb is you should make your documentation look like the documentation for the Java standard library. If you follow that link, that will take you to an article that tells you, it's a very long article, that tells you how you should write Javadoc correctly in a professional environment. Okay? All right, so I'll leave it at that. So that's the quick tour of Javadoc. So I guess in some lab sometime I will show you how to actually use the Javadoc tool to generate the HTML documents, the HTML documentation for your classes. But I'm not going to do it here. I mean, it's just using a tool. It's not that interesting. OK, this is about preconditions and postconditions of methods and constructors. Okay, so I'm going to talk about methods, but everything I talk about here is true about constructors as well. Right? So some methods require that one or more conditions be true before you actually run the method. Right? So in order for the method to run successfully, some methods require that there be some conditions that are met first, right? So for example, if you want to divide something, well, divide a point, the coordinates of a point by a number s, right? So I just want to divide the coordinates of a point by some scalar value. Then it's pretty important that the scalar value not be 0, right? Because you can't divide by 0, right? So for the divide method to run correctly, right, there's this precondition, or there's a condition on the caller that they not use 0 for the value s, right? So a condition that the caller of the method, so this is the caller, right? So whoever's using the method, right? If there's some condition that the user of the method must ensure is true, right, before they call the method, then that's called a precondition, right? It's a constraint on the caller of the method, right? It's not a constraint on the method, it's a constraint on the caller of the method, right? So the responsibility for meeting the precondition, right, that falls on whoever is calling the method. Okay, so if a method has a precondition, right, then it would be nice if you documented that precondition using Javadoc, right? There's a problem. Javadoc doesn't have a tag for preconditions, right? So there's no at pre or at precondition or anything like that in Java. In Javadoc, sorry, in Javadoc. Right? You can define your own tag if you want to, but there's no standard tag for it. Okay, so what does that mean? That means you're stuck documenting the precondition inside the method description or whenever you describe the parameter that has the precondition on it. Right? So for example here, this is divide. Right? Again, all divide's going to do is just divide the coordinates by s of the point. Right? So you scan through the documentation. There's nothing up here about any conditions on s. But when you read the documentation for the parameter, right, it tells you s is the scalar value to divide this point by. It must not be equal to 0. Right? So there it is. It's sitting. The precondition is sitting right there. Okay? So what this means is whoever calls this method better not pass in 0 for s. Right? Now the question is what happens if they pass in 0? Right? Okay. So the responsibility for meeting the precondition falls on the caller. Right? What that means is that releases the implementer of the method from having to deal with what happens if the precondition is not met. Right? So in other words, right, if you're the one that's implementing the method, you don't care if the precondition is met or not. Right? You just go ahead and do whatever it is you're going to do. Right? And as far as this whole, dealing with preconditions and postconditions is concerned, right, the implementer can do whatever they want, right, because the responsibility is supposed to fall on the caller. So for example, right, you can simply ignore what happens if s is 0. Right? So you just go ahead and divide x and y by s, right, and you carry on. Right? So that's it. So we're not going to do anything. So we told everybody, hey, there's this precondition, right? And then you completely ignore the fact that there's a precondition, right? If someone passes in 0, it's their problem, not yours. Right? Now that's so that's fine, right? Except that when you assume that a precondition is true, right? That's what we're assuming here, right? We're just going to assume the precondition is true and go ahead and do whatever it is we want to do. The problem is the method's going to run, right, with some argument that's not valid for the method. Right? So it's going to run for some input that the method can't handle. Right? And so now you ask, well, what can happen if you do this? Well, basically anything can happen. Right? The method might return the wrong value. Right? Some sort of error might occur. Right? So in other words, the method might end up throwing an exception that wasn't documented. Right? The method might not be able to do everything it says it can do. Right? And this means it doesn't satisfy what are called its post conditions, but we'll get to that in a second. Right? And if you're dealing with objects, what might happen is that method might end up putting the object into an invalid state. Right? So when you divide by 0 here, if you divide by 0, right, you end up with a point whose coordinates are either not a number. So if x or y is also 0, you end up with not a number. or if x or y are not 0, you end up with positive or negative infinity. Right? And so you end up with a very strange point, which may or may not be valid for a point 2 object. Right? But basically anything can happen. And you kind of want to avoid that when you're programming. Right? So for example here, if I have a point 1, 2 and I divide by 0, I end up with positive infinity and positive infinity. Right? Now the problem with infinity is you can't really do anything with it. Right? So if you try to do some sort of arithmetic with this, you just end up with infinity or not a number. Right? So this is not super useful for a point 2 object. OK, so instead of having a precondition, well, if you have a precondition, right, you should turn that precondition, you should turn failure to meet the precondition into an exception. Right? So if you have a precondition on a public method, right, you should check that the precondition is actually met. Right? If it's not met, then you should throw an exception to indicate to the caller that there's a problem. OK? And this is what almost every method or constructor in the Java standard library does. Right? So the classes in the Java standard library do not assume that the preconditions are met. Right? They actually do input validation on their arguments. OK, so what are exceptions exactly? So the term exception is short for exceptional event. Right? That's what exceptions are in Java. OK, so basically, so this is a quote from the Java tutorials. Right? So when an error occurs within a method or constructor, right, the method creates an object and hands it off to the runtime system. So it creates an exception object, gives it to the Java virtual machine. Right? That object's called an exception object. That contains information about the error, right? Including its type. So what type of exception was thrown, right? And it might include some information about why that exception was thrown. Right? So when you create an object and hand it off to the runtime system, that's called throwing an exception, right? And that's what the keyword throws does. Right? So to throw an exception, you just make an exception object, right? Like I've been showing you for the past couple of weeks. Right? There's a whole bunch of standard exception objects. Right? So there's a whole bunch of exception objects that are defined in this standard library. 3 of the common ones that you'll encounter are these. Right? So IllegalArgumentException, that's when someone passes in a value for an argument that the method or constructor can't deal with. Right? IndexOutOfBounds exception, that's when you try to index into an array or a list, right, with an invalid index. NullPointerException is when you pass in a reference that's null to a method or constructor. Right? So when the constructor tries to use that reference to call a method, when the constructor or method uses that reference to call a method, right, there's no object to call the method with. And that results in a null pointer exception. OK. So when you create your exception object, so you say new exception object, right? You use the keywords throws in front to throw the exception. Right? What happens when you throw an exception? Right? The method or constructor immediately stops running after the throws statement. Right? So any code that's after the throws statement doesn't run. Right? Right? So what does that mean for your constructors or for your methods? Right? So for your constructors or methods, right, if your constructor or method should throw an exception because there's an invalid input, then it should throw the exception before it does anything else, right? Especially in a constructor. Right? So in a constructor, you should not set the fields of the object and then throw an exception. Right? Because what ends up happening is that the caller can get back that object if they really try, and then they end up with an invalid object, right? Which you're not supposed to let happen. Right? So you should check your arguments first and then throw an exception before doing anything to the state of the object. Right? So for divide, you should check is S 0. If it's 0, you should throw an exception of some kind. Right? If you want to, you can include information inside the as a string indicating why the error has occurred. Right? So if you throw an illegal argument exception here, the caller will get back can get back that string where they see that they tried to divide a point by 0. Okay. Okay, so that's a precondition, right? So the responsibility of the precondition is on the caller. Now, what are the responsibilities of the method? Right? So the responsibilities of the methods are called the method postconditions. Right? So a condition of the method, so a postcondition is a method, a condition that the method must ensure is true when it finishes running. Right? Now, here the responsibility is on the method. Right? So if you're implementing the method, this is your problem now. Right? So now you have to decide what is it the method has to do, what is it that must be true after the method finishes running. Right? If one or more of your postconditions are not true when your method or constructor finishes running, you've done something wrong. Okay, now what do these postconditions look like? Right? So for a non-static method, right, postconditions can involve, right, the value returned by the method, right, if the method returns a value. The fields of the object, right? So if you have a method that's changing the state of an object, right, there might be a postcondition on the state of the object after the method runs, right? And if your method accepts references for inputs, there could be postconditions on what happens to those objects that are passed into the method. Right? So for example, if you sort a list where you pass in the list as a parameter, right, one of your postconditions is that the list is sorted after the method runs. Right? Okay, so the postconditions are normally described in the documentation of the method. Right? So basically the method tells you what it's supposed to do. Right? It tells you what it's supposed to return. It tells you what it might throw. Right? Those are all examples of postconditions. Right? So what's the postcondition on this method here? Right? Well, it returns the x-coordinate of the point. Right? Now, it's possible, right, but it's extremely awkward to express the postcondition as an actual condition in Java. Right? So remember, postcondition. It's a condition that must be true. Right? So in other words, it has to be a Boolean statement. Right? It has to be a logical statement. Right? But expressing these things as logical statements is incredibly awkward, as you will soon see. Right? So remember this method here? This just returns the x-coordinate. Right? That's all it does. Right? It doesn't change the x-coordinate, doesn't change the y-coordinate, it just returns the x-coordinate. So what is the postcondition on that method? Well, it's awful. Right? So I call the method, you call the method, the caller is expecting to get back the x-coordinate. Right? The coordinates of the point should not change after calling this method. Right? But how do you write that as a condition? Right? Well, I need to know what is the current x and y coordinate of the point when you call the method. Right? So I have to store those somewhere. Right? So I'm going to store those in two variables called old x and old y. I'm going to mark them final because I don't want to accidentally change old x or old y inside of the method. Right? The result is also final. Right? So the result's going to be this dot x. Right? And then I'm going to return the result. Right? And now you can write your postcondition. Right? Your postcondition is that this dot x equals old x. Right? In other words, the x-coordinate doesn't change. And this dot y equals old y. In other words, the y-coordinate doesn't change. And this dot x is equal to the result. Right? You actually returned the x-coordinate of the point. Right? That's what you have to write if you actually want to write a postcondition for this method. Right? Which I think you can all agree is awful. Right? However, there is a branch of software engineering called formal methods where you do exactly this thing. Right? So in other words, there's a branch of software engineering where you try to formally prove that a program is correct. Right? That involves writing preconditions and postconditions for every public method or constructor. And then some tool checks that every precondition and postcondition is satisfied when your program runs. Right? So there are programming languages where this stuff actually happens. Right? The types of programming languages that use this are the ones that are called mission critical. Right? So stuff where someone might die or something really bad or expensive might happen if something goes wrong in your program. Right? And so there's a whole very well-paid branch of software engineering that deals with this sort of thing. Right? But you can see it's really awkward to do. Right? Especially in Java, which doesn't have any mechanisms built into it that helps you write these conditions. Right? The languages that where you actually write these sort of things, they have facilities where you don't have to do stuff like this, right? Like get the original state of the object and stuff like that. Right? They do that for you automatically. So if you ever take a formal methods course, and I'm not sure if there's one here at Queen's, that's the sort of stuff you'll end up doing. Okay? Wait, whoa, stop. Okay. I think I will stop there before I continue on with any of the other post conditions, and we'll pick this up on Friday morning. All right.